Hello everybody and welcome to this third video on Introduction to Algebra and Function Pre-Calculus. I hope that you enjoyed the first two. Today we have basically one topic on the agenda, and this topic is simple factoring. The word says it's pretty simple. We're going to bring into this fairly elementary algebra operation some of the exponents that we've seen before to make it a little more interesting, a little more spicy, if you want. So basically, I think you pretty much all remember how to simple factor. When you have an expression, like for example, ax plus bx, simple like this, what you try to look for is what is common, yes, to the two terms that you have. Now, what is common to these two terms is quite obviously x, n'est-ce pas? So you take it out, and then I'm sure you know what follows up, because that's pretty straightforward. I'm pretty sure you would come up with here a plus b, and I don't think you need me to actually tell you how to do this. But really, do you? Here's the thing. Why don't we ponder 1 second on what we have done to obtain these two guys, a plus b. It looks pretty obvious. It looks like it doesn't need an explanation. But as the problems get more complicated, the explanation actually that I'm going to give you for this will help a lot. So what have we done to actually go from here to here? What is the actual algebra that we have done? We've identified, first of all, what is common to ax and bx, right? We've seen that it is x. So the common factor is x, no doubt. All right? So basically, in order to get this guy, what did we do really? We took the first guy, ax, the first term, and we simply divided it by the common factor. So this is the first term divided by the common factor. And of course the x's cancel out, right? It's x to the 1 divided by x to the 1, so x to the 0. And that's how I get a. Right? If I take a look at the second term, well, then it's bx. And if you divide this by x, what you're doing really is the second term divided by the common factor. Right? And of course you get x and x cancel, you get b, which is this guy. Simple enough, right? But basically very potent, because when the problems get complicated, applying this simple technique can really get us out of a mess. So this is what we basically apply throughout this easy lesson on, you could also call this introduction to factoring. There will be more factoring cases that will come later on. But for now, let us see if we can apply this to simple situations. So as usual, I have prepared a couple of problems that we can actually take a look at. So here we go. I have here example 1, which I believe we shall label with 2.5 stars. Remember, the barometer here is 1 star is very, very trivial, and 4 stars is very, very difficult. So this is like an introductory level here. So let's factor something like, what do I got here? 4x squared times y cubed minus 6xy4 plus 12 x3y2. So this, what I have here, is a trinomial because there are 3 terms. So clearly, if I want, and I do want, I can call this the first term, as this is the second, and as this is the third term. All right? So here's the standard way of doing this. First of all, well, if you want to call it, step one, find the common factor. What's the common factor? Well, it is what is contained in every term. So in this term there's a 4, then in this term there's a 6, and then in this term there's a 12. What is common to all of the numbers 4, 6, and 12? Does 2 go into all of these? Yeah, 2 goes into 4, 6, and 12. Does 3 go into every number? No, 3 doesn't go into 4. And that's about it. So I got to factor out a 2. Yes? Now, here's a little bit of a, not a secret, it's not a secret, not really a secret, not even a trick, it's something that people know mostly. How do I pick the x that is common to all three terms? Do I pick x2? Do I pick x1? Do I pick x3 as a common factor? I want to pick out an x. Why is that? Because there's an x in all of my three terms. But what's going to be the power? Now remember this, the power that is in the common factor is always the smallest of all the exponents, the lowest exponent, yeah? x2, x1, x3, so x1 is the smallest exponent. That's part of my common factor. Now, what about the y? Can I take out a y? First of all, yes I can, because the first term has a y, the second term has a y, the third term has a y. Let's take out a y. What's going to be the power? The power of y is going to be the smallest of 3, 4, and 2. That is your common factor. And then blah, 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 stuff will come here. We'll do this in step 2 if you want. All right, so step 2. Find the inside of the bracket. Find what goes inside of the bracket that is here. And how do I do that? Well, that's exactly what we did before. So let me do that again. To know what goes into this bracket, first I will do the first term divided by the common factor. Then I'll go second term divided by common factor. Then I'll do third term divided by common factor. And these are the guys that actually will go inside the bracket. D'accord. First term, 4x squared y3 divided by my common term, which we have already identified in step 1 as 2xy squared. 4 divided by 2. x2 divided by x1. Rules of exponent, that's 2 minus 1. Yep. y3 divided by y2. Again, rules of exponent division, 3 minus 2. That's y to the 1 again. And that's that. Second term. Where were you, my second term? You are. I'm going to leave the minus out here, and I'll bring it back in the bracket. Is that okay? I'll try not to forget about it. Remind me if I forget. Yell at me. Sir! So 6x y4 divided by my common factor, which is still the same, 2xy squared. Okie dokie. 6 divided by 2 is 3. X to the 1 and x to the 1. 1 minus 1, 0. No x's. Y to the 4, y to the 2. That's 4 minus 2. That's y squared. And that is the second term. Third term, 12x3y2 divided by 2xy squared. So what is happening here? 12 divided by 2, 6. x3 over x1, 3 minus 1 is 2. That's an x2. y2 over y2, 2 minus 2, 0. So y to the 0 is 1. These are the guys that go in the bracket. This and this and this will go into this bracket. Final answer. Let me put it over here, since this very small whiteboard does not contain much space. Final answer. Common factor, 2xy squared. And then, first term, 2xy. And then I'll try not to forget my minus. Yes, the second term here in the bracket will contain a minus, 3y squared. And the third term is a plus 6x squared. And that's that. That is the final answer to this simple factoring. Simple enough, right? Now I know what you're thinking. I know what you're thinking. Many of you are saying, how do I need to do this thing, first term divided by common factor? I already know by looking at it what's going to be like. That's okay. On simple problems like this, it's easy to bypass this approach. And if it works for you, it works for you. I'm not there really to change the way you think. I'm there to complement and to improve the way that you think. So if you can do the factoring of this directly without going through this analysis, go ahead. But I can guarantee you that as the problems get more complicated, as we get into the 3 stars and 3.5 stars, that little technique will turn out to be useful. All right, that was my first example. Good little introductory example. All right. So let's do exemple 2, which is still 2.5 stars. So factor completely this guy, a to the 5 over 2 multiplied by b to the 1/2 minus a squared b. So I promised you some fractional exponents. All of my examples between now and the end will actually contain stuff for us to practice our rules of exponent. This entire chapter is really about practicing our rules of exponents. All right, step 1, let us find the CF. Well, let us find the common factor. First term right here, and second term right there. All right, the first term has an A, the second term has an A. So for sure, I'll factor out an A. First term has a B, second term has a B. For sure, I'll factor out a B as well. The only thing that remains to be seen is what are the exponents. Remember, always the smallest of the bunch. A to the 5 over 2, a to the 2. That's 2.5, that's 2. So 2 is smaller. I choose the smallest of the exponents. I choose 2. B to the 1/2, b to the 1/2 is actually less than 1. Now that's my common factor. Super simple to find. A to the 2, b to the 1/2. Step 2. Looking for what is going to be inside of the bracket. What I do is I do my little analysis. First term divided by the common factor, and then I'll do the second term divided by the common factor, and that will tell me what is dans la parenthèse in the bracket. Alors, the first term is here. It's a to the 5 over 2 multiplied by b to the 1/2 to be divided by what we found in step 1, les common factor a squared b to the 1/2. All right, why don't we practice a little bit our rules of exponent here. That's one of the elements in this chapter. So that's a to the 5 over 2 minus 2 multiplied by b to the 1/2 minus 1/2. So that is a to the 1/2 and b to the 0. In other words, it's a to the 1/2. Second term, there's a minus here. I'm going to leave it out as I usually do, and I'll bring it back. Second term, a squared b is the second term, divided by the common factor, a squared b to the 1/2. So that, if I apply the rules of exponents, is a to the 2 minus 2 multiplied by b to the 1 minus 1/2. So that's a to the 0, and that's b to the 1/2. So that is just b to the 1/2. And we got what goes inside the bracket. Let's not forget that the middle sign is a minus. So final answer, let's put it here. Dans les squares, or les rectangles, common factor, a squared b to the 1/2, and in the bracket, a to the 1/2 minus b to the 1/2. You might remember that b to the 1/2 can also be written as the root of b, and that is the root of a, and that is the root of b also. Well, we'll leave them with those exponents for now. It's enough for the moment. Good. Let's see if we can hike up the stakes a little bit, for I believe that this is fairly easy. Well, this entire chapter is pretty easy. It's a question of practicing it a little bit, which we will do on our next assignment. So this is example 3. Let's hike this up a little bit. I don't know why there's a huge difference between examples 2 and 3. You'll be the one who can actually tell me if it is worth the extra half a star. So this is x minus 1 to the 5/2 plus x minus 1 to the 1/2. The first thing I want to say about this, although it's the same base, this is not equal to x minus 1 to the 5/2 plus 1/2. No, there is no such rule. Why? This is not a times, this is a plus. This is a plus. So there is no adding the exponents when the terms are separated by a plus or a minus. So, ça c'est pas bon. This is not equal to this. So what is it equal to? Well, step 1, the common factor. Step 1, the common factor. Clearly, first term has an x minus 1, the second term has an x minus 1. So the common factor has got to be x minus 1. And we choose the exponent as being the smallest of the two. 1/2 is smaller than 5/2. Step 2. And then we do what we have done so far. First term divided by the common factor. So the first term is x minus 1 to the 5/2 divided by x minus 1 to the 1/2. So let's do our rules of exponents here. Same thing on top and in the bottom. We subtract the powers, so that's 5/2 minus 1/2. That would simply be x minus 1 squared. Second term divided by the common factor will yield, what's my second term? It's x minus 1 to the 1/2 divided by my common factor, what we found in step 1 also, x minus 1 to the 1/2. Again, rules of exponent, x minus 1 to the 1/2 minus 1/2, which is 0. So x minus 1 to the 0, which is 1. Yep. So final answer, I'm going to put it here. I'm going to have two versions of this. So the first one here is going to be my common factor, x minus 1 to the 1/2. I'm going to put a bracket here, and then I'm going to put the first term here, x minus 1 squared. X minus 1 squared. The middle term is a plus, and what I found for the second term is just 1. That's a perfectly good and valid answer, but it's not fully simplified in the sense that I can open my brackets and collect my like terms. So here is another version of the same answer, this one even more simplified. What's x minus 1 squared? Well, it's x minus 1 times x minus 1. We've seen that before. And I'm going to cut to the chase here. I'm going to tell you right away that it's x squared minus 2x plus 1 plus 1. So that is another version of the same answer where the bracket x minus 1 squared has been expanded. And if I collect my like terms, then I get the actual most possibly simplified answer for this. x minus 1 to the 1/2. And here I will simply have x squared minus 2x plus 2. Now that is probably a little better simplified than the other one. All right, good enough. Let's see if we can do another one, perhaps hiking up again the level of difficulty. So, exemple numéro 4, I'm going to put here an extra half a star, so 3.5 stars. You'll see why in a moment. This guy has some negative exponents which many people do not like, but we still have to be able to handle them in this course because we are going to meet them in Cal 1. All right, factored this completely. Again, I'm going to stick to my guns. I'm not going to start talking about bringing this down and having common denominators and stuff like this. This will be covered in a later video. I just want to tackle this according to the method that we have had so far because it seemed to have worked fairly well. So, step 1, I need to find the common factor. What is the common factor? Well, common factor between this and this, it's clear that they have something in common because they are both 2x plus 1 in the bracket. So factoring out 2x plus 1 to some power is pretty much what we want to do. What's going to be the power now? Again, always pick the smallest of the two, so minus 1/4, 3/4. I want to pick out minus 1/4. Comes up. Step 2. Step 2. Then I look for what's going to be in the bracket once I take this as a common factor. Okay. Again, this is relatively boring now that we know exactly how this works. First term divided by le common factor. So 2x plus 1, whoops, sorry, I died. Smudge. 2x plus 1. This is my first term, minus 1/4 is the power, divided by 2x plus 1. And the common factor is also minus 1/4, so it's not hard to see that this is 2x plus 1 to the power of minus 1/4 minus minus 1/4. We all know that this is 0, and the first term in the bracket shall be something to the 0 is 1. Second term divided by common factor. Here's my second term, 2x plus 1 to the 3/4, 2x plus 1 to the 3/4, and that is divided by 2x plus 1 to the what? What's the exponent of the common factor? Minus 1/4. Okay, same base, so subtraction of exponents. 3/4 minus minus 1/4 is 4/4. That's 2x plus 1 to the power of 4/4, which is just 1. Yep. So I guess we are ready to box our final answer, at least one version of it. What's my common factor? 2x plus 1 to the minus 1/4. What do we got here for the first term? We got a 1. Well, there's a minus here. And then what do we got for the second term? We got 2x plus 1. And that is a perfectly acceptable answer. But we will want to simplify this. There's a part in Calculus 1 where you are going to encounter exactly expressions like this. And the way we have it here is not going to be sufficient to obtain the information we need. It's going to have to be simplified furthermore. So here's one version. Not yet the final one though, but a good one. 2x plus 1 to the minus 1/4. And then here, if I take in the bracket, I'm going to have minus 2x minus 1, and 1 minus 1 will cancel out. Right? This is, let me do it here, 1 minus 2x minus 1. So I'm left with only minus 2x. That is a better answer. But you know what? We're going to be better off in both this course and the next, and the one after that, and the one after that, and we're going to be better off if we don't leave negative exponents in our answers. So I want to get rid of this and come up with my absolutely final version. I have a negative exponent here. We all know what this means. We got to bring it down. And the negative 1/4 simply becomes positive 1/4. And that is a much better answer than the one that we previously had. All right, that was a bit more challenging, huh? Because of the negative powers. So let's do one last. Let's do one last in this video, since we're getting close to half an hour. And I don't like to actually go over the 30 minutes per video. So I want to do one more. I want to do something actually simple. I think I'm going to bring this down to just 3 stars for my example 5. You'll be the judge. Factor completely 2x plus x to the minus 1 plus x to the 0. So 3 terms for this guy. All right, so first term, second term, third term, first term, second term, third term. I wish to find something that is common to all of these 3 guys. If there's nothing common, then there's no simple factoring. So, oh, this guy has an x, this guy has an x, this guy has an x. So clearly, step 1, the common factor will involve an x. Common factor will involve an x. Remember that we always pick the x to what? Highest or smallest power? Yes, smallest. Power 1, power minus 1, power 0. That's the winner. X to the minus 1 is going to be my common factor. Step numéro 2. So, first term divided by common factor. 2x divided by x to the minus 1. So that is 2x to the 1 minus 1, right? Power 1 here, power minus 1 downstairs. Division is subtraction. Yo, this is 2x to the 1 plus 1, 2x squared. Second term divided by a common factor. I will get here second term, which is x to the minus 1, divided by itself. So what's that? This is x to the minus 1 minus 1. This is x to the 0, which is 1. Good. Third term divided by common factor. My third term is x to the 0 divided by the common factor. So that's x to the 0 minus 1. This is equal to x to the plus 1. Good. So, first version of our final answer, but probably not the very last, would be common factor always comes in first. And then first term, second term, third term, they are all pluses. So 2x squared plus 1 plus x. That's a perfectly valid answer. But we have just mentioned in the previous problem that règle générale, generally speaking, we are better off without having negative exponents in the picture. So we will actually get rid of it, and we will reorganize the trinomial in the bracket so that we have the powers of x in descending order. So x squared should come first. It's right there. And then I'm going to change the places of the 1 and the x because I want x2, x1, x0. It's neater way to write it down. So here's 2x squared plus x plus 1. And this guy goes downstairs. It's a negative exponent, so it comes down as x to the 1. I don't really have to put the 1. And that is the better of the answers that we can actually get. And that's simple factoring for you guys. So in the next video, we will expand our scope of factoring. So basically, we'll talk about things that you know, difference of squares, perfect trinomials and stuff like this. And then after that, we'll be on our way to simplifying rational expressions, and we'll get into stuff that are closer and closer to the actual calculus that we will study next semester. In the meantime, I hope that this video was instructional. Instructive is probably a better word. I wish you well, and I'll see you soon. Take care now.